Looking at question 2, it says white blood cell counts are normally distributed. That's good, normally distributed with a mean, this is the truth, of 7,500 and a variance of 500. If a patient has taken 50 lab tests that have a mean, this is X bar, and a standard deviation, that would be S, does this give evidence that his white blood cell count is significantly different than normal? So what I'm going to end up doing here is a one sample. We've got one sample here, and I could either do a Z or a T test, but since I know that the true standard deviation is the square root of 500, I'm going to do a one sample Z test. And I'm going to test to see if mu is normal was 7,500, or is it different than 7,500? Now, again, I should define my terms. I should show some work. But the idea with the requirements is that I need to have a simple random sample. I need to make sure that I end up with a normal distribution or a large sample size. And it told me I have a normal distribution. And third, if I'm going to do a z-test, I know sigma, and sigma is the square root of 500. Now, if I was writing this out, again, I need to be a little more detailed with my requirements, but that's not the point of this worksheet. This is going to be a two-sided test. I don't have degrees of freedom, but my z is x bar minus mu over sigma divided by the square root of n. The catch, and the big thing to notice, is that the variance was 500. So when I plug this into my calculator, I'm going to do see if I can make that a little bigger. I'm going to do a t-test, z-test with the data. Nope, with the stats, because I don't have the individual values. The mean was 7,500. This is the square root of 500. So I could just write it just like that. X bar was 6899.75. I did a sample of 50 lab tests, and we want to know a two-sided test. Calculate, chick, where I get a very, very small p-value because the z-test statistic is so tiny. My guess is that when the original person made this worksheet, they didn't intend to make one of them the variance and one of them the standard deviation, but they did. And so that's what we've got right here. The test statistic then is negative 189.82. The p-value is basically 0. And with such a tiny p-value, I reject HO in favor of HA.